So welcome everybody. I'm Mike Shanahan. I'm the Planetarium Director at Liberty Science Center in Jersey City, New Jersey. Our planetarium is called the Jennifer Chalsty Planetarium. It opened about 2.5 years ago. It was a renovated domed theater. And when we became a planetarium in 2017, we became, by doing that, the biggest planetarium in America, 90-foot dome. We really hope that when travel begins again, you can all come and see us in our main dome. During this time of closure, Evans and Sutherland, who makes our great software that runs the planetarium, has given us the okay to use their software online to deliver the planetarium to your own home screens. So we'll be using that during our program to bring the night sky to life and to travel into deep space, and for that matter, to Sicily. During our program, we have Andrew, our other planetarium educator, on this webcast. He'll be in the chat. You can go ahead and ask your questions to him, and we'll leave some time at the end of the program as well to address questions that have come up. So any astronomy questions you have, please go ahead and use the chat box to correspond with us. We are, like all nonprofits, trying to carry our mission forward in these trying times and to keep STEM education and the love of astronomy alive in our area and throughout the country and beyond. If you feel like donating, there is a donate button there, and it would be great to have you support us as well in our mission to keep the astronomy flame alive in these times of closure. So we're going to begin our program by going where all astronomy has its beginnings. We're going to go to the nighttime sky. In this case, we're going to begin our show. We're going to, in the course of our show, talk about asteroids, how we discovered them, what they are, some missions to asteroids, and what the challenges are in terms of them someday hitting the planet Earth again, as they almost certainly did 66 million years ago in the days of dinosaur extinction. So we're going to begin by going out to the morning sky, as you would have seen it in late May. So here we have the sky you would have seen just before the first light of dawn in late May, and we're looking south. The constellation of the Scorpion is there, a classic constellation of the summertime, although it's actually just about to set here at 4:30 in the morning here in late spring. The stars of the Scorpion have been in the same pattern for thousands of years, so we can use a name invented by the Babylonians 2,500 years ago for our constellations of today, because the stars are so far away they really don't move in a human lifetime. You won't find Antares here going this way next week, and this star is not going to go that way. The stars are like cars on a really distant freeway that barely seem to move because they're so far away. On the other hand, the planets are more like cars going right in front of your apartment or house, where you can actually see them move pretty quickly. So in the morning sky here in late spring 2020, we have 3 planets clearly visible, and you can actually see these in the sky now as soon as it clears up outside, which I think it's going to do by tomorrow. The planets Jupiter, Saturn, and Mars. And unlike the stars that make up the Scorpion or any other constellation, these planets can be seen to move against a starry background over even just a few days' observation. You won't see them move as you look at them, but you'll notice, if you observe over a week, that they are changing their positions. Planets like the planet Mars, in fact, move pretty quickly. They're near the sun and move faster than Saturn and Jupiter do. So Mars is pretty much of a speed demon, visibly changing its position within a couple of days. Saturn and Jupiter, much further from the sun, move more slowly, although the real speed demon in all of this is the moon, which whizzes across the entire sky once every 30 days. So here's the sky. We've taken it like right up to the sky of this morning. So if you are an early riser tomorrow morning, check this out. The blazing planet Jupiter due south, the planet Saturn next to it, and then Mars further to the left. But what you're going to really notice is Jupiter. It's really, really bright at minus 2.5 magnitude, the brightest dot of light you can see until Venus comes into the sky at the end of June before dawn. So planets move and stars don't. Now that really impressed the Greeks, who named the planets after the most important thing they could think of, the gods and goddesses of their culture. So you have Jupiter, the king of the gods, Saturn, the god of wisdom, and Mars, the war god. So when the telescope came along, trying to find planets in the telescope, kind of the distinctive thing about it being a planet, if you found a planetary suspect, a planet date as it were, is that if it moved against a starry background, you probably were finding a planet-like object. But amazingly enough, even though the telescope was invented in 1609 by Galileo, no one found a planet with a telescope until 1781, about 170 years later. And that discovery was made from Bath in England by William Herschel, who was a German musician and an amateur astronomer. So this time was a big time for amateur astronomy. He made his own telescope that was actually better than the telescopes that the Royal Observatory had, about 8-inch diameter, 7 feet long. Herschel was a musician by trade. Many great astronomers, scientists, and so forth were also musicians. And his passionate hobby was astronomy. And so using this actual telescope in March of 1781, March 13, from his backyard, he discovered a new planet. He noticed a bluish-white dot in his telescope that at first he thought might just be a comet, but he observed this over a number of days, and sure enough, it moved against the starry background, just as we saw Jupiter and Saturn and Mars move against the starry background. And so the Royal Society confirmed pretty quickly that yes, indeed, he had found the first new planet since the beginning of time. Now, he wanted to name this planet the Star of George, in honor of George III, the King of England at that time. You know him. He's the guy that we rebelled against in the American Revolution. He's also a key cast member in the musical Hamilton, who sings the song, You'll Be Back. But Johann Bode, a German astronomer, suggested instead, well, historically all the planets have been named for figures in mythology, so we should still do that with this new planet. So instead of calling it George, let's call it Uranus, after the father of Saturn, which made sense. You know, the planet discovered after Saturn is named for the father of Saturn. So Uranus was a name given to it. It's made the life of me and all my fellow planetarium folks a little bit difficult. There is no way to say the name of that planet that doesn't get giggles from 8th graders. Uranus, whatever, but that is the title, and that was why it was chosen. It actually makes sense when you explain it that way. So this kind of got planet hunting interest going there in 1781. This fact that another planet had been discovered by William Herschel led many other amateur astronomers to search the skies. One of them, Johann Bode, also believed that there just had to be a planet in between Mars and Jupiter because there was just too much space between those two planets not to have a planet there somewhere. So sort of a club of planet hunters formed in Europe, all over Europe, Italy, Netherlands, Germany, England, and they made it their hobby and their passion to try to hunt for new planets, either between Mars and Jupiter or way out beyond the planet Uranus. So to carry the story forward, we're going to go to the workplace of one of these planet hunters, Giuseppe Piazza, Italian priest in Palermo in Sicily. We're going to fly to Sicily and follow him as he observes the sky in 1801. So we're going to leap off of Earth, which the Digistar allows us to do. And as we're leaping off of Earth, we're going to get probably a really good view of Home Sweet Home. And for those of you who don't know the geography of our area, I can stop here and point out right here is the Jennifer Chalsty Planetarium, the one we normally use for our programming. Here is the rest of our science center. We are located in Liberty State Park, a very large park in Jersey City. And if we keep on going, we'll get a better view of our overall neighborhood. So if you try to find Liberty Science Center again, you're going to find it right there as our planetarium. Here is the overall giant park we're in. But also notice we're really close to Manhattan. Here is Manhattan. Here is the Statue of Liberty is there. Here is fabled Brooklyn in this direction. So long story short, we're really close to New York City. So when things lighten up again for travel, it'd be great if you could come over and join us right across the Hudson at Liberty Science Center. We're going to keep on going. We're getting high enough momentarily down in the corner here to even catch briefly Central Park. And now we're going to head over, first day of 1801, heading over towards Sicily off the boot of Italy. So one planet has been discovered with a telescope. And now we're going to go and look at things that are much smaller than planets. I saw a question saying asteroids. Yes, we're on the road to discovering asteroids. We're heading over Spain. There is Madrid, this great blaze of light. And here is the boot of Italy. So here is Italy, and here is Rome and Naples. And down here at the toe of the boot is the large triangular island of Sicily. And we're heading for Palermo right here on the northern part of Sicily, heading for the Royal Observatory in the Royal Palace in Palermo. So Giuseppe Piazza was a priest who was also the curator of the observatory here in Palermo. And he was in that club of folks who are trying to find new planets in the sky. But he actually, on the night of the 1st of January, 1801, he wasn't trying to find any of these hoped-for new planets in the sky. He had a very precise measurer that he could use for star distances and was trying to create better star maps than the ones he had been using in the past that were sort of the common star maps of his time. So he's looking in the sky towards the constellations of Orion the Hunter and Taurus the Bull, familiar constellations you can see from Sicily as you can see from here in New Jersey. And looking in between the face of Taurus and the Pleiades was the part of the sky he was examining. And as he was examining that part of the sky, he noticed an object too dim to be seen with the naked eye, 7th magnitude, that he thought was a star that earlier star maps had just not been able to record. He thought it was a mistake. It was a little tiny dim dot. And even though he had a good telescope, he couldn't make it into any more than just a point of light. It would never appear to be a disk. So he thought he had discovered a star that hadn't been recorded on his earlier star maps. But as I was saying, he had really precise measuring devices. And in the course of one night, here on January 1, 1801, in the course of one night of observation, he could tell this little dot of light was moving against a starry background, much as Jupiter did, much as Uranus did. And so he came to realize he had discovered a planet-like object, but he was baffled because no matter how good the magnification, he could never make this into a disk like Uranus. It remained a little tiny dot. So other astronomers in his group throughout Europe wound up observing and confirming this, and they realized that it had to be really tiny if they couldn't magnify it into a disk. And so Herschel, who also saw it in the wake of this discovery of Father Piazza, suggested the term asteroid. Aster is the Greek word for star, so it's a star-like object. They knew it was part of our solar system, but it remained a little tiny dot even in the best telescopes. So the term asteroid got used sort of interchangeably with planetoid and planet, at least until the middle of the 19th century. So this priest Piazza had discovered on the first day of 1801 the first asteroid ever discovered, and he got to choose a name for it. He chose the name Ceres, C-E-R-E-S, the Roman goddess of the harvest and of grain. And that was actually a really great choice, probably a better choice than Uranus, in that in mythology, Roman mythology, Ceres lived in Sicily. So this first asteroid discovered from Sicily was named for the goddess whose home was right there in Sicily. So other astronomers learning of this discovery, even in these war-fraught times, it was a really rough time for Europe with the Napoleonic Wars going on and kingdoms falling left and right. They got the information and tried to find Ceres themselves. And so 15 months later, in 1802, Wilhelm Obers was looking in the constellation of Virgo, trying to find Ceres. And lo and behold, he found a whole nother asteroid, which he then named Pallas for the Greek god of wisdom, which just by sheer coincidence happened to be right in the same part of the sky as Ceres. So now you found two asteroids within 15 months of each other. In 1804, another member of this team of European observers found Juno, the third asteroid ever discovered. And then March of 1807, the fourth of the gang of four, the first four asteroids ever discovered, was discovered again looking in the constellation of Virgo. Looking at the constellation of Virgo, the asteroid Vesta was discovered. So that's four asteroids discovered very quickly in the first 7 years of the 19th century. But then there was a drought for just about 38 years, and no more asteroids were discovered. So four were discovered, all by these amateur astronomers who shared their information with each other throughout Europe and did all this amazing work in incredibly difficult times where the Napoleonic Wars were raging, kingdoms were falling, restorations were happening. And they still found these four asteroids, realized they were quite tiny, and realized they had to all be in between the orbits of Mars and Jupiter. So one theory these astronomers had was that maybe there had been a planet in between Mars and Jupiter that had been blown apart. Not Bonaparte, he was the guy they were fighting, but blown apart by the gravity of Jupiter and broken into smaller pieces that formed the asteroids. They thought that in part because they had discovered Ceres and Pallas like right next to each other. All right, so let's go ahead now and leave the beautiful island of Sicily and head deep into the solar system to observe the asteroids as we know them to be in their main habitat, the asteroid belt that lives in between the orbits of Mars and Jupiter. So heading to the deep solar system, the orange orbit is Mars, the white one is Jupiter, and in between we have these million or so asteroids. You can see all the ones we were talking about. There's Vesta, there's Ceres, and there's Pallas, three of the four asteroids originally discovered by those intrepid observers of the early 19th century. So most of these asteroids can be as small as, say, 5 or 6 feet in diameter, or as big as Texas, which is roughly the size of Ceres, the biggest asteroid. Now, we first got to see what asteroids look like thanks to the Mariner 9 mission, which traveled to Mars in 1971. Both of Mars's moons are captured asteroids, so it's a special deal where we were able to see what asteroids look like on an early mission to Mars, because these moons of Mars are in fact captured asteroids. So asteroids tend to be small. These are Manhattan-sized and also tend to be oblongy instead of spherical. Now, interestingly enough, the theory, of course, was early on that maybe the asteroids were caused by a big planet being torn apart. In fact, it's the opposite. The power of Jupiter, the gravity of Jupiter, ensures that all of these bits of debris in the asteroid belt never coalesce into one big planet. So Jupiter does have a role in the asteroids, but its role is to stop them from gathering into a big planet. So there never was a big planet, and there's really not a lot of mass in the asteroid belt, maybe 4% of the mass of our own moon. So NASA has set a number of missions to asteroids, and this one here is called the Dawn mission. Dawn was launched back in September of 2007. It's spelled D-A-W-N, by the way. Dawn that way, not D-O-N, like a person's name. The Dawn mission was on a trip to go visit 2 of the original 4 asteroids. It was going to go to Vesta first and then on to Ceres. It took about 3.5 years to get to its first stop. This is the first mission in the history of robot probes to go to one celestial object, orbit it, and then leave that object and go to another celestial object and orbit that as well. We've had flybys, many flybys of various planets, but never had this kind of mission before. So here again, there's the orbit of Mars, there's the orbit of Jupiter. Dawn here is not to scale, and we'll catch it as it takes its 3.5-year voyage to catch up with Vesta, the first of its 2 stops, and the 4th of the asteroids ever discovered. The official name, by the way, is 4 Vesta, which means it was the 4th asteroid ever discovered. In the same reasoning, Ceres is actually officially called 1 Ceres because it was the first asteroid ever. So as Dawn approached Vesta, it would actually go into orbit and orbit this asteroid for about 14 months. Vesta, like most asteroids, does have kind of a potato-y shape to it. And it's also very reflective. In fact, Vesta is the only asteroid that you can see with your naked eye under the right circumstances. It's fifth magnitude when it's at its brightest. So Vesta, early on in its career as an asteroid, was banged up pretty heavily by its fellow asteroids, and this created deep gouges in the surface here. In fact, little bits of Vesta were knocked off by early collisions and wound up going into the deep solar system, and eventually a few pieces of Vesta wound up landing on Earth. And so we were actually able to analyze certain meteorites on Earth that came from Vesta to get a better idea of the nature of this asteroid. So it's about the size of New York State. Vesta is about 325 miles in diameter. Here are the tallest mountains rising about 2 miles above the surface. So Vesta had a guest for approximately 14 months before Dawn moved on to its second and final destination. So it fired its rockets and it headed off to the first asteroid ever discovered, and still the biggest asteroid, the asteroid Ceres. It's about 580 miles in diameter. Ceres is roughly the size, a little bit smaller than the state of Texas. And Ceres is quite a bit different than Vesta. In fact, there's a lot of icy elements in Ceres. Now, they would expect that Ceres would be very heavily cratered. And it is, but it's not as cratered as they expected it to be, because cryovolcanoes, volcanoes ejecting ice onto the surface, have covered over a lot of the older craters here. There is some evidence of ice in this moon Ceres, although still very heavily cratered. Now, Ceres also only asteroid that has a distinct, completely round spherical shape. And Ceres has one more claim to fame. It now is officially considered 2-in-1. It is both an asteroid and it is a dwarf planet. It's the only asteroid large enough to be considered a dwarf planet. As you may remember, there was a decision made in 2006 to reclassify Pluto as a dwarf planet, because we were finding so many Pluto-sized objects out in the very deep solar system. Eris, which is roughly the same size as Pluto, also Haumea and Makemake, a little smaller but in the same category, and then Ceres. So all of these other dwarf planets are in the very deep solar system, the Kuiper Belt, far, far from the sun. But Ceres actually is the one that is nearer to the sun, that still belongs to this club of the dwarf planets. The spherical objects that are not massive enough to clear their own orbits, and basically are now considered to be dwarf instead of planets. So Ceres, I don't know if you want to consider it a promotion or not. The promotion actually made Pluto the king of the dwarfs. It's still the biggest one. And Ceres now is, again, a 2-for-1, both a asteroid and a dwarf planet. So the main asteroid belt does kick in material towards the inner solar system occasionally. And we do have probably 20,000 asteroids that lie in the inner solar system, called near-Earth asteroids. And these are the ones, again, supplied by the main asteroid belt that we're concerned about in terms of impact on Earth, especially the really big ones. So in this view, we're coloring the near-Earth asteroids blue in color. There are, again, 20,000 of them. About 1,000 of them are big, at least 2/3 of a mile. And they're, again, supplied by the outer asteroid belt. And these asteroids that are near the sun, that cross the orbit of the Earth, are a major cause of concern in terms of asteroid impact. And we do know that asteroids do hit the Earth. There have been many examples of that historically and in deep time as well. So the most well-known example of an asteroid impact in the last 150 years happened over Siberia on June 30, 1908. There was a giant explosion in, fortunately, a very remote area of Siberia that knocked over 80 million trees. It was a time of many, far more massive and then many hydrogen bombs going off simultaneously. Fortunately, this region was not very heavily inhabited. There were no actual proven deaths that occurred in this great explosion, but it caused a vast amount of destruction in the forest here. It's called the Tunguska Event for the area of Siberia where it happened. And it took a lot of analysis, but they did come to realize eventually that, yes, indeed, it had to have been caused by an asteroid, probably in the range of, say, 60 feet in diameter, hitting the atmosphere and exploding over this part of Siberia. By the way, the UN now considers June 30 as International Asteroid Awareness Day, and they chose that date because that was the day of this explosion in 1908, June 30, 1908. So that date's coming up in less than a couple of weeks. So that, again, over Siberia, an example of what can happen when a fairly small near-Earth asteroid hits our atmosphere. But you may be familiar with another event that happened just a few years ago in the area of Chelyabinsk in Russia. And a meteor, maybe 6 feet in diameter, came in and hit the atmosphere and caused an amazing fireball. So here's actual footage of that fireball from February of 2013 coming in. Now this hit the atmosphere, probably 6 feet in diameter, exploded high up, but the shock waves shattered windows over a wide area of Chelyabinsk. And actually, of the 1,500 injuries that occurred, most of these were in fact due to this, the shockwave breaking glass. Folks ran to the window to watch the impact, and then the glass shattered when the shockwave hit. Certainly one of the most filmed impacts in history, in part due to the popularity of dashboard cams here in this area of Russia. So fortunately, we've had two major impacts that did not result, as far as we know, in any fatalities, although a number of injuries came out of this one here in Chelyabinsk here in 7 years ago. But it really raised the awareness. Yes, these can happen. These will happen. Asteroids will strike the Earth and can cause a real great deal of local disruption, even for a smallish one, like say 6 feet in diameter, like the one that came in over Chelyabinsk. But what if an asteroid that's not 6 feet or 60 feet or 600 feet, but what if an asteroid 6 miles in diameter hits our planet? Then what would the impact be of that? Well, that is the idea behind what is now the most accepted theory for what killed the dinosaurs. And I've been in this field long enough to remember when this was kind of a wild left field theory. And it kind of unfolds like a detective story. So basically, Walter Alvarez, a young geologist in the 1970s, was analyzing the odd fact that there seemed to be a layer of clay containing iridium, which is very common in space and not common here on Earth, in various areas of Italy that he was studying. And this layer of clay was in between two areas of limestone. One area of limestone had lots of little tiny fossils in it. Then you hit the layer of clay above it, and above that, the next layer of limestone, all those little fossils didn't exist anymore. Iridium common in space, not common on Earth. Fossils disappearing. He was quite mystified, and as time went on, they discovered other areas that also had this clay layer around the world. So Walter Alvarez, the geologist, got talking to his father, a famous physicist, Luis Alvarez, and they developed this theory that a comet impact is what could have killed the dinosaurs and wiped out most of life on Earth. The idea being that an asteroid about 6 miles in diameter would have hit the Earth. At the immediate impact, it would have caused volcanoes and earthquakes and mega tsunami and wiped out most of the creature life in that general area. But even more impactful, the matter sent into the atmosphere would have lingered in the atmosphere for years, blocked off the sun. Plants would have died, then plant-eating dinosaurs would have died, and then meat-eating dinosaurs who eat the plant eaters, they would have died, and you would have had eventually the loss of dinosaurs, and actually 75% of all life on Earth being wiped out. So they put this idea forward in the 1980s, but a big debate was, well, where could this have happened? So the current theory developed in the 90s was that an area off the Yucatan in the Caribbean, there seems to be a basin that is where the impact actually occurred. There are shock waves down there. There's evidence of iridium. And so the best bet is that this 100-mile under-the-sea crater off the Yucatan is where the impact occurred. And more information seems to suggest, yes, this was where that 6-mile diameter asteroid came in. So all these factors have gone to really underscore the significance of possible asteroid impact. And actually 2 popular movies as well in 1998, both summer mega hits, Armageddon and Deep Impact, got the idea in the public that this is a concern that we should be paying attention to. And so how do we track it? What's being done about it? Well, we have the whole organization that tracks all asteroids. The Minor Planet Center has about 1 million of these in their database. And also there's now about a dozen different organizations that monitor the heavens for near-Earth asteroids. The Linear Project out of Lincoln Laboratory here at MIT is one of them. There's also one in Hawaii called Pan-STARRS that also monitors the sky to try to catch these near-Earth asteroids. And the good news is they're doing a great job of catching near-Earth asteroids. The problem is they're finding an awful lot of them. So here, this column here is last year, 2019, and here are all the asteroids. So nearly 2,500 near-Earth asteroids being picked up by these different tracking organizations. The green line are all the ones found by the Catalina survey, and the pink line, the Pan-STARRS project, found those ones. So they are there, and a question then becomes, well, what do we do about it in terms of being ready when the big one hits? So the term Deep Impact actually was not only the name of a movie in 1998, it was also applied to a NASA mission that went to Comet Tempo 1, and they put an impactor that blasted into the comet while the main probe held back and analyzed the matter coming from this comet. So it shows that it is possible to send a rocket to a comet, a small target, or an asteroid, more importantly, and be able to either impact it to change its course or to blow it up. A lot of other ideas. Could we use a solar sail to block sunlight from hitting a given asteroid and just in that change of dynamics of the temperature cause it to drift a little bit away from impacting Earth? Or here's an opposite idea here of having a solar focuser reflector going in between an asteroid and the sun, using the light of the sun to blast the asteroid, and the impact of the matter being burned off the asteroid would cause the asteroid to propel itself out of the way of impacting planet Earth. So there's a lot of great ideas out there. There's not a major asteroid expected to come our way in the near future, but it is a thing that's going to need a lot of attention. Stephen Hawking, the great astrophysicist, in his final book in 2018, said the biggest danger to life on Earth is, in fact, an asteroid hitting our planet. So they are tracking it really well. The ideas are developing now, although there's more to come in terms of how we're going to deal with this down the line, hopefully hundreds, if not thousands of years down the line, when a large asteroid heads for us. So that is our program. Thank you for joining us, and we'll now check some of the questions we have in the chat as well. Someone pointed out that birds are dinosaurs. Yes, so not all life was wiped out when the big one hit 66 million years ago, and certainly a number of creatures survived and dinosaurs evolved into birds. Yes, Cindy is wondering, what is the biggest asteroid? And that is Ceres. Again, C-E-R-E-S is how it's spelled, and that is 580 miles across, so roughly just under the size of the state of Texas. Yes, small life, Joey is saying, would have been able to hide or at least find some way to hunker down. I mean, with the big impact, mammals were able to kind of hunker down and survive in many cases, and we were able to eventually take over the planet as mammals, with the dinosaurs having been sent on their way by the giant asteroid. Reese is wondering, why does Jupiter have a red spot on it? Well, Jupiter is a giant ball of gas that has no solid surface. Jupiter has heat coming from the inside, and Jupiter spins really fast. It spins once every 10 hours, and that generates a lot of storm action on the upper layers of the clouds of Jupiter. So in fact, Jupiter's red spot is a giant hurricane. Been going on at least 200 years, maybe for millions of years for all we know. How are meteors formed? Dilraj is asking. Meteors are formed basically when the solar system was formed. Everything coalesced into the sun first, and then the other matter around the sun began to gather into planets. But some matter was never gathered together to form a planet. For example, where the asteroid belt is, there the tugging of Jupiter just prevented large other objects from forming in the asteroid belt. And so because of that, the debris that was coalescing into the planets elsewhere in the solar system was never able to come together into a single planet. And so instead, these were the asteroids. And then a lot of them drifted in towards the inner solar system, and little bits of debris, both from comets and from asteroids, wind up hitting the Earth's atmosphere, burning up from the friction as they come in careening into our atmosphere and causing the shooting stars that we know and love. The middle of August, by the way, the most famous shooting star shower of the year is coming up, the Perseid meteor shower on the 11th and 12th. There's no moon to interfere this year, so it's probably a really good year to try to get out there and try to find a shooting star. So yeah, Carla is wondering, did other prehistoric creatures get wiped out? Yes, many, many other kinds of creatures were wiped out, not only dinosaurs, although mammals were able to survive the impact. What are meteors made of? Someone is asking. Meteors are mainly composed of stony, rocky, mineral materials. That actually raises a good question. A question we often get is, how is a meteor different from a comet? Comet material tends to come from deeper in the solar system and has more ice. Ice and dust generally is what makes a comet. And they tend to be these little, the term is dirty snowball, until a comet gets near the sun, where the tail tends to glow as the comet's dirty snowball warms up. Whereas asteroids tend to be mainly rocky, although some, as we saw with Ceres, do have elements of water as well. See if we have any more comments here as we go through our... How do we know when the next one's going to hit? So the next asteroid, we are monitoring it constantly. Again, there's about a dozen organizations now that scan the skies looking for asteroids coming our way. Interestingly enough, we also found many, many comets by these same searching features that are also primarily intended to search for asteroids. And so they're using now computer surveys of the sky to scan the skies, looking out for asteroids that might eventually impact the Earth. But along the way, they've also discovered many, many, many comets. So actually, many comets that you hear about have the name like Pan-STARRS or Linear of the organization that found the comet while hunting primarily for near-Earth asteroids. Are there other impacts we know of in terms of asteroids? Well, yeah, certainly the Meteor Crater, for example, in Arizona is a really good example of a giant impact caused by space rock slamming into us long ago. Oh, here's a great one from Monica. Do asteroids have moons? Great question. And the answer may surprise some of you. Yes, many asteroids have their own moons. And so it's actually very common to have a small asteroid, maybe 100 miles in diameter, with a smaller moon orbiting it. So even though 2 of our planets don't have moons, neither Mercury nor Venus have moons, a number of asteroids do have moons. Pooja is wondering, which planet is the fastest spinner? The biggest planet is the fastest spinner. It takes Jupiter only 10 hours to spin around once. So a day on Jupiter is only 10 hours long. The length of a year for every planet is just a matter of how far it is from the sun. But things are all over the map in terms of length of day on planets. And so, for example, it takes 243 Earth days for Venus to turn once on its axis. But Jupiter there and all of the outer balls of gas, Saturn, Uranus, Neptune, spin very quickly. How big can meteoroids be? Well, there's a lot of fuzziness sometimes in definitions. Meteoroid is often used for a term used for any space rock that's 1 meter, that's about 40 inches or less. So they tend to call it a meteoroid if it's 1 meter or less, 39 inches. And beyond that, it winds up being called an asteroid. So all the objects that hit in, the 2 that hit in Russia, for example, let alone the one that hit here in the days of dinosaurs, are all considered asteroids. Kara's wondering, Pat's wondering, could there be life on an asteroid? Good question. At one point, we think Ceres maybe had an under-the-surface ocean, much as we know exists at the moon Enceladus around Saturn and around Europa at Jupiter. So if at one time Ceres had an under-the-crust liquid water ocean, on Earth, life forms wherever water occurs. Who knows if there could have been life forming back in the old days when Ceres had that liquid ocean. But we're thinking probably not, because you generally need water in some form for life as we know it. And unless you have a subsurface ocean, it's kind of hard to have any kind of water in environments, which is true of all of the asteroids, that aren't large enough to have any kind of atmosphere to hold in water on its surface. Arlene is wondering, is there a difference between asteroids and meteors? So asteroids, the term meteor specifically applies to a little bit of space debris that hits our atmosphere and burns up. So when you see it in the sky, as you're out there watching the Perseid meteor shower in mid-August, it could either be a little bit of asteroid or a little bit of a comet. Both comets and asteroids, little bits of them are what strike the atmosphere and cause shooting star showers. Whereas asteroid and comet are the big objects whose little pieces eventually hit our atmosphere, burn up, and become meteors as they come careening through the atmosphere. Well, Michael has a great question there. Does Jupiter get hit by asteroids? Yes, Jupiter gets hit by asteroids and by comets as well. Jupiter is such an enormous force that it pulls in many objects to it. And another piece in folks really coming to believe that asteroid impact on Earth was a danger occurred in 1994 when the comet Shoemaker-Levy was seen to impact the planet Jupiter. And so when they saw a major comet break up and slam into Jupiter, and they got really clear images of that impact occurring in 1994, that was one more piece that really sold folks in the fact that, well, if a comet or asteroid could hit Jupiter, the same could happen to our home planet. I'm thinking that probably also drove Hollywood to say, hey, what if we do a movie on comet or asteroid impact? And again, 2 competing movies both came out in 1998, Deep Impact and Armageddon, both dealing with the what-if scenario of impact from space. Nancy's wondering, if a planet or asteroid has a moon, then it has gravity. Yes, they all have gravity. They don't have much gravity because the mass is so small for an asteroid, but they do have gravity as well. And so they can actually, they have enough of a pull to hold on to their moons, much as the Earth is able to hold on to our own moon. And Mukund is wondering, do asteroids have oceans beneath them? Great question. As far as we know, the only one that ever had an ocean was Ceres. And that we are pretty sure now Ceres has lost its under-the-sea ocean. Although we can see features on Ceres, again, Ceres, the biggest asteroid, that seem to have been caused by erupting ice volcanoes that covered over some of the craters there. So yeah, Marilyn is wondering what a comet is. So as we learn more about comets and asteroids, sometimes it gets a little fuzzier, but generally comets are formed in the very deep solar system and are comprised mainly of ice and dust in a very kind of loose gathering of material, whereas asteroids tend to be big, rocky things. And only comets, because they have ice embedded in them, as they get near the sun, generate those beautiful tails that we see coming off. The ice sublimates, turns into a gas, and you have these beautiful sights. Podmina is wondering how a meteor shower happens. So basically it's just space debris hits our atmosphere going really fast, and that friction, which you can imitate by just rubbing your hands together, causes a little bit to burn up and then causes that glow in the sky. And there are both asteroids and comets, mainly comets, who've left little puddles of debris that are in the wake of the Earth's orbit. So every year we wander into different little bits of leftover comet material. And every year, as we hit that material, a shooting star shower happens at the same time every year. So we wander into comet debris every August 11 and 12, and little bits of comet burn up, and then that causes the Perseid meteor shower every year. Has Mars ever been hit by an asteroid? Yes, Mars also. Now, Mars has got much lower gravity than the planet Earth has. It's a much smaller planet, so Mars actually has far less gravity, but it also does attract asteroids. In fact, it attracted two of them that became its two moons, Phobos and Deimos, but it also was heavily impacted, and there are many, many craters on many parts of Mars that are evidence of Mars being hit back in the old days. Marilyn's wondering what was significant about Halley's Comet. So Halley's Comet was significant in part because it was generally a very bright comet, although its last iteration in 1985-86 was probably the worst appearance of it in many, many, many centuries. But it comes back very predictably. It was in part made famous by the fact that Edmund Halley, the great astronomer in England, predicted its return. Long after he passed away, it came back as he had predicted, and it really showed that a lot of the thinking of Newton and Halley and the new generation of astronomers really knew what they were doing in terms of predicting the behavior of our solar system. And in 1910, the appearance of 1910 was a very beautiful appearance of Halley's Comet. And so it generally had been a really great comet, although if you're in my business, you come to realize you got to be really careful in promoting comet appearances. There was a comet called Kohoutek in the 70s that had a big buildup for it, and it was a total non-event. And in the late 70s and 80s, we had the term Kohoutek to describe an event that was supposed to be great that wound up being a bomb. Like, how was that party last night? Oh, it was a real Kohoutek. And then sometimes comets like two in the 90s that you don't expect to be big become these beautiful sights in the sky that you can actually see even from our big cities. So comets are interestingly unpredictable, but if you see one, they're extraordinarily beautiful, these beautiful streaks in the sky. Would an asteroid or meteor ever hit the sun? Yes, yes, yes. The sun is a giant force of gravity. So actually, talking about near-Earth asteroids, they have to have a constant regeneration from the main asteroid belt, or there wouldn't be any near-Earth asteroids because they'd all be sucked into the sun or be thrown out of the solar system by the sun's powerful gravity, or they would hit Earth or Venus or some other planet. And so, yes, many, many, many of them hit the sun, this massive gravitational force in the center of our own solar system. Gloria is wondering, was our moon an asteroid before? Great question. So our moon, unlike the two moons of Jupiter, our moon is not a captured asteroid. But we think it had an asteroid-like birth, because long ago, billions of years ago, in the early days of Earth, another object, I guess you can consider an asteroid, from the forming solar system struck Earth so violently that the Earth nearly broke apart, and a huge piece of Earth was knocked off and gradually coalesced into becoming our moon. So our moon was born of the Earth by being hit by another big piece of primordial matter. So you can think of that as being an asteroid. So you could say probably that the moon was caused by an asteroid collision, but the moon itself is actually an object that was birthed out of our own early Earth. Yeah, someone is recommending calling Bruce Willis. Yes, two big hit movies. It's kind of a fun game in our field to point out all the inaccuracies in both of those asteroid movies, Armageddon and Deep Impact, but they still did help to popularize the idea of this impact from space being a really good consideration. Kate is wondering, we'll take a couple more questions here. Is Mars red or orange? Kate, Mars is orange. So why do we call it the red planet? How do we find a scorpion in the constellation that we call the Scorpion? the active human imagination, I think, saw the color red in what was really a very, very, very pale orange. But if you're in a really dark sky, especially when Mars is close to Earth, as it is every couple of years, the scintillating appearance of Mars can make it appear to turn a little bit red, although it primarily is an orange-colored dot of light in the sky. But imaginations that saw the Scorpion in those stars of that constellation had no problem seeing the color of blood or whatever in the shade of Mars. And so Mars has always been orange, but long ago became called the red planet and identified with the war god Mars, maybe because that red reminded folks of fire or of the color of blood. It's also, of course, where we get the word Martial in our language, comes from the word Mars, and the month March also comes from Mars. The Romans loved Mars. They named the first month of their calendar March in honor of the war god. They were kind of into that whole conquering thing. Hey, Marilyn, what is going to cause a solar eclipse on the 21st of June? So a solar eclipse is only caused during a new moon, when the new moon gets right in between the sun and the earth and blocks off the light of the sun. And when the moon completely blocks the solar disk, which is blazingly bright, you have the most awe-inspiring sight in astronomy, the pale glow of the outer atmosphere of the sun shining around the moon. And it's an awesome sight, and if you ever have a chance to see a total solar eclipse, mark your calendars, book your hotel rooms now. Buffalo in 2024 is going to be in the path of a total solar eclipse. I believe it's April of that year. But this eclipse that's happening on June 21 over in Europe and such, it's going to occur when the moon is a little further than normal in its orbit from the Earth. And it's not going to be big enough to entirely block the light of the sun. There'll be a ring of sunlight shining around the moon. And if just a little bit of sun gets past the moon, it'll still be blindingly bright, and there'll be none of that amazing, eerie sight of the land going dark. It's called an annular eclipse, from the Latin word for ring, because you see a ring of sunshine shining around the moon. And it's a cool thing to look at through a safe viewing filter, but it's nothing like the awesome spectacle, as we'll see in South America on December 10, during that total solar eclipse, of a land going completely dark when the sun is completely blocked by the moon. Can humans live on an asteroid? You'd have to have all the amenities there. You'd have to find somewhere to get water and to grow your own food. But it shouldn't be undoable, especially for a largest one like Ceres. And the asteroids are a little closer to us than the planet Jupiter. Right now, in terms of going to the planets with a human mission, the only option is Mars. Venus is unbearably hot. So is Mercury much of the time. And Jupiter is way too far away. So one alternative could be to go to an asteroid as maybe the next step beyond going to the planet Mars. Okay, checking here to see if any... What planet do you think is the next survivable planet? Chris is wondering. Well, Mars is a survivable planet. Mars is cold as Antarctica, but it's not like miserably horrible like Venus, which is always 807 degrees down there in Venus. And Mars has a thin atmosphere. You'd always need a spacesuit on Mars, but it's by far the most hospitable. So beyond that, there aren't really many other options unless we want to try getting a human mission going to the asteroid Ceres, for example. See. What would happen if Jupiter got hit by a black hole? Purvi is wondering. So Jupiter, there's no black holes anywhere near us, and so Jupiter, like the Earth, is not in danger of going into a black hole. If there ever were to be a case, like say, where we merge with another galaxy and the black hole in that galaxy got close to Jupiter, then Jupiter would be, if it got too close, pulled in, stretched out, and absorbed by the black hole. But that is not, unlike an asteroid impact, that is not a concern that we need to worry about here in our lifetimes. But yes, that's the only way I can imagine Jupiter going into a black hole, is we'd have to collide with another galaxy like Andromeda, which is going to happen, but not for 4.5 billion years. So I wanted to mention also, we do have all of our programming saved on our LSC website, LSC in the House. So all of our past astronomy programs are there. If you want to learn more about black holes, we have a show on that. We did a galaxy show last week that's there. We have a show on the supermoon, a tour of all the planets, and many others. And then next week, Andrew's going to be doing a show in this time slot on Jupiter, Saturn, and the July nighttime sky. Again, if you want to support us, we'd really appreciate that. And I'd like to thank you all so much for joining us for this program. And we do hope to see you all next week at the same time for Jupiter, Saturn, and the July nighttime sky. Thank you all.